All right, guys, welcome back. Now, what we have learned already, what we learned is basically some practical approach to measure blood pressure, and also what does it really mean. All right, so we talk about the brachial artery measurement. We talk about the device to use, and then talk about how do we measure it, right? And this blood pressure basically is a pressure. The purpose is to measure, try to get into the aorta, but brachial artery is the closest for us to measure the aortic artery. So that's that. So that's what we know. All right. Then the next thing is that we want to know the theory behind this blood pressure. As I already kind of like talk about um, the blood pressure is involved in two things. One is how much of the blood pump out from the heart. So the harder it is, the more blood got pumped out, the more fluid, right? So your pressure will increase. So that's one factor to the blood pressure. Another important factor to influence blood pressure is blood vessel size. So if vessel become narrowing, it will become very difficult for water to go through. And so the fluid pressure will be higher when the blood vessel is narrowing. So the theory is very simple for the blood pressure, which is that there are two factors influence the blood pressure. These two factors are these two, heart and the blood vessel. Blood vessel. For the heart, the factor influence it is the cardiac output. We talked about the cardiac output already, and we are going to talk about it again. The amount of the fluid get out of the heart, the amount of it, right? Each time is a stroke volume, and you can pump it very fast, so heart rate. So cardiac output equals stroke volume times heart rate. We talked about it in the previous lecture. The other one is vessel size, so diameter. The narrower it is, the more resistant it provides. So TPR is the total peripheral resistance. And you times these two, it gives you the blood pressure. It's not like mathematically time. It's not like the cardiac output equals stroke volume times heart rate. We can mathematically time these two together. This one is more like ideal, like cardiac output times like multiply the total peripheral resistance will build up the blood pressure. So that's that. Let's first look at the cardiac output. So cardiac output is the blood coming out from the heart. Heart is like a pump, right? We know it. It's pump. It squeeze it, squeeze it, squeeze it, squeeze it, squeeze it, squeeze it. Well, it's not anything new, right? You squeeze the air to pump your tire, or you play soccer, you will pump your air your soccer ball, right? So this is something not new to us. Everyone has some life experience with these, right? Don't tell me you never use this. I'm not that old, right? Yeah. So something like this. So when you try to air a tire, for example, you want to increase the amount of the air to get pumped out, you can have two options. One is that each time just do it larger, right? You can do that. Or you can just do it faster, right? And so you can have small amount but faster, or larger amount even faster. So these two factors will influence how much air get pumped out. Something applied to the heart. So in the heart, cardiac output equal stroke volume. So stroke volume is each time you can pump out from the heart. And the heart rate is how fast you pump it. And overall, we got the cardiac output. All right, so this is the one that we talk about. And that will give you the blood pressure. The higher cardiac output, whether that is stronger stroke volume or faster heart rate, you got a higher blood pressure. So when you have pump faster, your blood pressure increase. When you dehydrate, your stroke volume decrease because you don't have enough fluid. When you dehydrate, your blood pressure decrease. When your blood pressure decrease, you don't have enough blood going to the brain. Chaotic baroreceptor right here will sense it. Then it will trigger your heart to pump faster in order to maintain good blood pressure. That's the homeostatic loop that we talk about in our lab, in our very first lab, and we will also talk about it again in our next lab. So that's that. So that's the cardiac output. This one, the higher cardiac output, the higher blood pressure, right? So that's that. The next thing is TPR, total peripheral resistance. This is about the blood vessel to influence. So total peripheral resistance is that when the blood coming out, it goes through the vessel. And you need to know that we have a lot of vessels. We have the artery, capillary, veins. Capillary is very, even though each one is very small, but you have a lot of them. So actually the resistance in the capillary is very low because you have just wide open, like wide spread capillary through our body. Whenever you get a cut, you got a capillary because that is where we have substance exchange. That's where you can provide the tissue with the oxygen. So you have capillary everywhere, but you don't have artery everywhere. You don't have veins everywhere. So those two regions are the region to provide you the resistance. When you have an artery atherosclerosis, hardening, you increase the resistance. So the resistance, theoretically, three things can influence the resistance. The length of the vessel. So the longer it is, the longer resistance is. Usually this doesn't really apply to the physiology because we don't just randomly increase the length, right? But we usually what affects is these two, viscosity of the fluid. If the blood become thickened, why is that become thickened? Some disease will cause blood flow to blood become viscous, become very sticky. Yeah, so that could be one. Another one is more common one is the vessel diameter. So if it become narrowing, this is very common. Atherosclerosis will make the blood vessel become narrowing. That's probably the most common one. Yeah. And so with that, you increase the total peripheral resistance, TPR. By increase total peripheral resistance, you increase blood pressure. So this one show you that blood vessel can contrast. Here is a smooth muscle. You have smooth muscle in artery. You also have smooth muscle in veins. So the both can do the contraction. When they contrast, you reduce the diameter. We call this one a blood vessel constriction right here. Vessel constriction. When smooth muscle contrast, you cause vasoconstriction. Maybe I can have that as a quick question. When blood vessel, smooth muscle contrast, would that cause vasoconstriction or dilation? It causes vasoconstriction. Yeah. And if the muscle relax, it causes vasodilation. Yeah. When the endothelium cell is injured, when there is some injury, you tend to cause vasoconstriction. There are several reasons. One reason is that that is just the tendency of the smooth muscle. When the smooth muscle got irritated, they will cramp, they will contrast. Another reason is that when there is injury, say the vessel would think that there is leakage. So they will try to contrast in order to prevent too many fluid coming here and get leaked out. So injury will also tend to cause the vasoconstriction in order to prevent losing your blood. Yeah, so there are several and that is why hypertension is dangerous. Hypertension, that high pressure will damage the endothelium cell, and gradually you will make the vessel become highly sensitive. and to any like irritation, and so they will become narrowing, and you increase by the narrowing, you increase TPR, you increase blood pressure. So it's a vicious cycle that you just make it blood pressure higher and higher and higher, which is not a good thing. So that's why know your blood pressure and do a management to it. Yeah, so that's that. All right, so that is a theory of the blood pressure. We have only one equation, only two factors. One is the cardiac output. The other one is the total peripheral resistance. So blood pressure involved is influenced by these two factors, cardiac output and total peripheral resistance. All right, yeah. Basically, this will be the quiz question, right? What's the relationship between BP, CO, TPR? What's the relationship between this one, CO, stroke volume, heart rate? Okay, so that's that. All right, let me know if you have any question, okay? Let's take a break. We will talk about our body's regulation of the blood pressure.